Alright, so you guys would have worked on 10.1 part 1 yesterday. Today we will talk about circumference, is what we're going to start off talking about here. So the circumference of the circle is the distance around the circle. So if you kind of took a string and wrapped it around a circle, that distance, that length of string would be your circumference of the circle. Okay? And pi, we use this symbol here. To as pi, and it's just the ratio of circumference to a circle's diameter. So it's the ratio of circumference to diameter, which we often just use 3.14. We use pi equals 3.14 is what we round it to, but in all actuality, pi is irrational. Okay, this decimal continues on 3.14159, a lot more digits there. We usually round it to 3.14. However, in this course and on the calculators I have, we've got a button. The scientific calculators have a button. Okay, you'll find this on the calculators. We'll talk about it in class a little bit, but there's an actual pi button. So, should be familiar with pi. And why? Well, when we talk about circumference, okay, if a circle has diameter d or radius r, the circumference equals the diameter times pi. C equals pi times diameter. Or you can use, of course, diameter is just 2 times the radius, so you could also use the radius 2 pi r. Alright, so either one works, of course. If you have the diameter, you can find the radius. If you have the radius, you can find the diameter. So either formula works here. So let's continue on to some examples here. So example 4 here, we're going to find circumference. So find the circumference of each circle described round to the nearest hundredth. So again, our two formulas, C equals pi times diameter or 2 pi r. We use both here. Okay, in this first example, we're given radius is 2.5 centimeters. So we'll use the formula that has circumference with respect to radius. I'd use this one. So circumference is 2 times pi times 2.5. And I'm going to use the scientific calculator here, one of them in my class, and you just plug in 2.5 times 2 times, you'll use the pi button, and when you plug that in, what you get is 15.70796, and it keeps going on. It's irrational. Okay, and we want to round to the nearest hundredth, so that's 2 decimal places. So to do that, we're looking here. We're trying to round to 2 decimal places. So this 7 rounds the 0 up. So 15.71. Again, if we're given units, we need to use units. So 15.71 centimeters. Right? And the next one, we'll use C equals pi times diameter. We're given the diameter. So C equals pi. In this case, we'll keep 16. We've got diameter. So on your calculator, use pi times 16. And you get 50.26548. Keeps going on. And we want the nearest hundredth, so 2 decimal places. A 5, we got to round that up. So 50.27 units here. That's how you can find circumference of a circle using those 2 formulas. So example 5, we're going to find diameter and radius given circumference. So find the diameter and radius of a circle to the nearest hundredth if circumference is 106.4 millimeters. So just to decide which one you want to find first, I'll find diameter first. We recall circumference is pi times diameter, so just substitute this for our C. So 106.4 is equal to pi diameter. Pi is just a number. Remember, 3.14 is what we usually round it as, but in this class we'll use those scientific calculators. So 106.4 divided by, use the pi button, and you get 3.868117. So that's what we get for diameter. We want it to the nearest hundredth, so let's round to 2 decimal places. 33.87 millimeters would be the diameter. Once you have diameter, pretty easy to find radius. Just divide by 2. So radius is diameter divided by 2. Recall that from yesterday. So to find radius, I would just 33.87 divided by 2. 33.87 divided by 2. And you get 16.935. So our radius, again, to the nearest hundredth, 0.94. And that is, we've got our units millimeters. All right. Let's continue then. Okay. A polygon is inscribed in a circle if all of its vertices lie on the circle. A circle is circumscribed about a polygon if it contains all the vertices of the polygon. Quadrilateral LMNP is inscribed in circle K. Circle K is circumscribed about quadrilateral LMNP. So you can see we've got both of those things going on. We've got that the polygon is inscribed because circle K goes around it, and we've got that the circle is circumscribed about the polygon. All right. So circumference of a circumscribed polygon. So we'll take a look here at example 6. So find the exact circumference of each circle by using the given polygon. So we've got a circle here, and I'm going to use the tools again today to make a circle. A circle here, and it's telling me it's got an inscribed right triangle. So let's make a right triangle. What is unique about right triangles? If you inscribe a right triangle in a circle, the hypotenuse is actually the a diameter of the circle. So if it's a right triangle, the hypotenuse, and this just comes from the fact that this inscribed angle, if you guys recall, all the way back to 10.1, I know it's been a while, but if you recall, if an angle in a triangle, if it intersects a diameter, that makes it a right angle. So this is a right triangle. We're told it's a right triangle, so it intersects the diameter. So that segment is diameter. All right, well, this right triangle has legs of 7 and 3 meters long each, so we can use the Pythagorean theorem here. 7 squared plus 3 squared would give me my diameter squared. That gives me that hypotenuse, which is the diameter. So 49 plus 9 diameter squared. So here, the diameter would be the square root of 58. And of course, there's a decimal value for that. But if we want to find the exact, that means we're not going to round. Okay, so we will not round. We will use circumference equals pi times diameter. We know the diameter, square root of 58, so circumference is square root of 58 times pi times that. So that is the circumference. Our units are meters. So pi, square roots of 58 meters. Okay. This next example, we have a circle, and we've got, it's telling, so I'm going to go ahead and make a circle. And, okay. And we've got a square that is, yikes. Yikes. Okay. Let me get rid of this. Try again. Actually, I'm just going to draw. Okay, we've got a circle with a circle that is, the circle is the square is circumscribed. So the square goes along the outside, and that's not a bad free-handed square. All right, and it tells us that the sides of the square are 10 feet. So if the sides are 10 feet, then it would also be true that here in the middle would be 10 feet. That segment I drew there, of course, is a diameter. So circumference is, pi times diameter. Pi times diameter. So circumference here is 10 pi. Substitute 10 to our diameter. And that would be our exact circumference. So, all right, you guys go ahead and can finish up the homework then here, which is the part 2. Of course, you guys have done part 1 already, 10 through 21. So now we want to do 22 to 33 all. All right, have a wonderful afternoon. Thank you for watching.